Hey folks, welcome to another video about the electric Suzuki Sidekick. I know it's been a while, but today I thought I would take advantage of the nice weather and let some light in the garage and talk to you about the charging system and how we charge this little rig. Pretty important for any EV, and so let's go ahead and get to it. Obviously, you can watch my other videos if you want to know more about the vehicle itself, so there it is. But charging happens back here. So first I'll show you the charger itself. So go ahead and set the camera here. So this is the only major component of the build of the EV system that I had to mount inside the vehicle, interior compartment. I had intended to prevent that entirely, not have to put anything inside, but as it turned out, I ended up putting the charge connector back here in the back end, and it just really fit nicely to put this charger right here on the side above the wheel well. And this also keeps it nice and protected, and in the wintertime, what tiny bit of heat this thing generates as it charges helps to pre-warm the inside of the vehicle. So this charger is a Thunderstruck Motors TSM 2500. I believe the 2500 means that it's capable of 2.5 kilowatts, but you have to supply it with 240 volt power to do that. And the way I've got it set up, it's only utilizing 120 volt, so I can only charge about half that rate, so about 1.25 kilowatts. In reality, it generally charges at a maximum rate of just a little over 1 kilowatt. Now this charger, as you can see, has a cooling fan. The cooling fan just runs continuously as long as it's charging, even though at the rate that I charge, I don't think this thing ever really gets more than maybe slightly lukewarm. It really is running under its capacity at that rate. What you can see here, this is the power coming in from the charge port, which I'll show you in a few minutes, into a connector and supplying the unit, and then the output is here. That's the DC headed to the battery pack, in this case at about 120 volts, and I've got a big connector here as well. So I tried to build this so that it could be removable and replaceable without rewiring anything. Now the main reason that I bought the TSM 2500 was A, the price was good, and B, it's fully programmable. A lot of the do-it-yourself EV chargers that were available when I built this rig required you to specify your charge curve and send it to the seller, and they would pre-program it at their facility and then send it to you. And once that was done, you were stuck with that charge curve until you sent it back to them to have it reprogrammed if you ever chose to. And me being the tinkerer that I am, I really wanted to be able to adjust my charge curve to my liking if I decided that I wanted to change it. So the TSM 2500 also had the option to purchase this little charge control module here, the EVCC version 3.0. This can connect to my computer, and with a very simple, almost DOS type interface, I can configure all the charge curve parameters. So of course, this being lithium ion chemistry, we do a constant current followed by constant voltage charge curve. So in this case, because I'm only using 120 volt power off of a regular household wall outlet, we've got the programmer set up so that we run a constant current of whatever the wall outlet, whatever the charger supply will give it. And I'll show you that in a few minutes. So there's a communication that happens between this charge controller and the charging supply. And so it'll run as fast a current as it can from the supply until it hits a preset voltage. And I believe I'm setting at 121.5 right now on my nominal 120 volt pack, and I got that number off of these are, if you haven't watched my other videos, I've got Chevy Volt packs in this this rig, and the Chevy Volt cells were tested by the Department of Energy, and they published a charge curve for the Chevy Volt cells. So I took their data and basically backed it off just a little so that I'm a little bit safer as far as the top end, and used that as my top end voltage. So once the charger sees the battery packs hit that voltage, it starts slowing the current down and slowing down and slowing down until, and again, this is something based on my research, they say that you should stop charging at 1/10 of the current that your bulk charge rate is at. So if we're charging at 15 amps, which is, it's not quite 15 usually, but say we're charging at 15 amps during the constant current phase, and then we hit constant voltage and we start slowing down, we cut off charging at 1.5 amps, and that's what I've got this set up for. But this little programmer allows me to adjust all those parameters. It also allows for the capability to do multiple charge profiles. So if I had it connected to a switch up front, I could have, you know, like a full charge profile that even pushes even a little higher, maybe 122 or 122.5 voltage, to try and squeeze a little more power into the packs. Or if I had more power available, I could have a different charging rate profile. But because we just don't usually drive this thing that far, and charging rates are just not a big deal, and I'm trying to really conserve the battery packs and be really easy on them, right now we're just using the one charge profile all the time, and it has worked fine. Not a whole lot else to show or to talk about in here. This whole thing is aluminum. You know, it's fully finned here. Very good heat transfer if it needed to, but like I said, running at basically half capacity, this charger just doesn't get very warm. It's not been an issue at all. The little fan does make a little bit of noise when it's running. In fact, that's the best way that I've found to tell if charging is finished or not, if I can hear the fan running here. So let's go on the other side, and I'll show you a couple of more things about charging this rig. So I don't know if it's by design or pure luck. Oh, I guess we got to go to the driver's side because we have to pop the fuel door. This is one of those vehicles with a fuel door latch. But in any case, I don't know if this is how the J1772 ports were designed or if it's pure luck. But as it turns out, here's the fuel door. The J1772 port fits just perfectly in the old gas filler hole. All I had to do was remove, of course, all the gas fill pipe and all that stuff from the gas tank, and drill a couple of additional holes and bolt this J772 port or J1772 port into that fuel filler hole, and it fit just perfectly. I did not have to cut or bend or do anything to the sheet metal at all. It was I was shocked at how easy that was. So the way this thing works is there's a little latch here. You push that button and it's got a sort of a, I don't know, slow opening hinge there for some reason. I guess that's just to make it feel like it's not flimsy. And it's got an O-ring seal in here. If you can see that, it's a little dark, I apologize. But that keeps the moisture and dust and everything out of the charge port. You can see it's nice and clean, even though the vehicle is very dirty these days. And as it just so happens, all this stuff fits just perfectly. You can see the latch for the fuel door. It goes right between the J1772 hinge and the latch that holds it in there for the vehicle. And then on the other thing is true on the other side. This little latch just barely fits next to the fuel door, but everything works. I didn't have to bend or hammer or anything to make this fit. So what do we plug into that? So what I did is I purchased, this is kind of a cheap Chinese power supply here, but it just has a regular 110 volt plug into the wall outlet on it. I think you could probably replace that from this side with something, if if you're in a different country or whatever, to have a different outlet plug. And then it's got this little readout on it, and I'll show you that here in just a second. But this little box is what communicates through the J1772 protocol with the charger, and this little box actually is pretty neat. It gives you some information about charging. So let's go ahead and plug this in. Now this is going to be hard to see because the readout, although it gives a lot of good information, it is very, very dim, especially in daylight like this. So I don't know if you can read that at all, but the largest thing there is the number 15A, and that's telling us that it's set up for a maximum current of 15 amps. And that's the way it came from the factory. And then it says the word ready because it's ready to be plugged in and start charging. The very upper right hand corner has the number of kilowatt hours that it has supplied, and that's a totalizer. So until I unplug it from the wall and reset it, it will just continue to totalize the number of kilowatt hours. So I can charge the vehicle, drive it, come back and charge it again, and it will just add on more kilowatt hours to what it has supplied. Underneath that is a clock. It just gives the total charge time. It's also a totalizer, just keeps adding up. Below that is the current wall voltage that it's receiving through the wall outlet. Right now reading 124, 123, 125, just bouncing around a little bit. And next to that, right now it says 0.0A. That's the current amperage rate that it's feeding to the charger. As soon as we plug it in, then that number will start to rise. And the last item on the right side below that says 0.00 kilowatts. And of course that is the power rate that it's supplying to the charger. So that number would be a positive number if it was charging. And then in the lower left is the temperature. It monitors the temperature of this little box, make sure it doesn't overheat. It's got some lights up here at the top that are just telling us kind of the status, and that's that. It's pretty simple, but very effective. I've used it, I don't know how many hundreds of times we've charged this thing now, and it has been flawless. On the other end of the long, thick cable from the box is this J1772 charge connector. And this is the exact same thing that you would find at a commercial EV charging station. Of course, this one is only supplying at what they call level 1 charging rate because it's only being supplied by a 125 volt outlet. So the best it can do is about 15 amps at 125 volts. So, you know, somewhere between 1 and 1.5 kilowatts. Like I said, in practice, we're getting just a little over 1 kilowatt. So it has this lock button here that locks it onto the plug, and this rubber cap to keep it clean. So if we pull the rubber cap off, you can see that it actually has 5 pins, and that's because of course it has the hot wire, the neutral wire, and the ground wire, but it also has 2 pins for communication. And I mentioned that earlier. That's where the little box over here, that's kind of the brains of this power supply, actually tells the charger controller how much power it's capable of supplying, and that way the charge controller knows how fast to charge. So if we just open the port and then just go ahead and take this, and again, there's another piece that just barely fit without any modification. This slides right in and clicks. And then I don't know if you could hear it, but this box had a relay click inside. And now you can see instead of the green light that says ready, we have a red light showing we're plugged in. And I'm just starting to hear the fan spin up in the charger inside, and we're starting to get some amperage. We're reading 5.4 amps and about 0.65 kilowatts. Now, the reason those numbers are so low right now is because this battery pack is essentially fully charged. So we're already into the constant voltage phase, and it'll only charge over a few minutes here, and then it'll shut down because I didn't drive this since I unplugged it last. One other thing that this charger provides is this little indicator light. It's set up so that you could mount it into a panel. It's got a panel mount configuration, but because I put this charger right here next to this back window, I decided, well, I'll just use a clamp and mount it right in the window so I can see from the outside. And essentially the color is intended to indicate the state of charge, and that's pretty rough because that's just based on voltage. And typically the way this one runs, I only see it either flashing yellow or green. Right now it's green, like I said, because this battery pack is almost still fully charged. We're not going to put much power into it on this charge cycle. And then I don't know if you can hear the fan running from the outside. It's pretty quiet from the outside, but in here you definitely can hear the fan run, but it's not too bad. And then that same indicator light flash color scheme happens on this interior light you can see in the upper left there. Again, I don't really look back here at all when I'm charging, so that's pretty irrelevant to me. So I think there's only one other thing I wanted to mention about charging this little rig, and that is when you're charging with a garage outlet that has a ground fault protected circuit, make sure that your circuit has a high enough capacity and that your GFI protection outlet is in good condition. And even at that, sometimes you may still have some issues. My point, the reason I bring that up is right under here, under these shelves, is the outlet that we use for GFI protection on the circuit that we're using. And it's a 20 amp circuit with a 20 amp GFI outlet. But even at that, when the weather gets really hot, this is a south facing wall on this side of the garage, that GFI will get too warm and it will trip when I'm charging. And that's, when I say hot weather, I'm talking about over 90 degrees Fahrenheit outside with the sun hitting that wall. And it's a brown painted wall, so it gets really warm. But just so you know, this thing, the charger pulls a lot of current, and if any part of your circuit is a little bit weak or under stress of some sort besides the charger, you may have to do something about it. For us, I basically have just in the hottest days of the summer, I wait till the evening to charge anyway. We're on time of day billing. That's another thing to consider with charging an EV is your power bill. If you can charge at off-peak times and get cheaper power, you definitely should do that. Again, that's another reason I have to charge when it's cooler in the summertime at night, because the power is like half the price. So not that we're using more than a few pennies worth of power every day to run this little rig a few miles around town here, but you know, every bit makes a difference. So anyway, thanks for watching. If you have any questions about charging, post them in the comments. I'll see what I can do to answer them, and hope you have a great day.